All right, so in this video, I'm going to be covering my advanced overlay tool. The best way to think of this tool is similar to the decal actor, but it gives you a lot more control. What this tool does is it actually projects a procedural mesh onto whatever surface or surfaces you select, and you can have any type of material for the most part that you want to have on that surface. And when it projects that procedural mesh onto the surface, it is actually modifying the vertices of that procedural mesh to match the surface that it's projecting onto. This is a lot easier to use than the standard decal tool because it allows you to easily modify which objects and surfaces that the overlay is being applied to. If you're using a decal actor, then you have to go in and create a stencil and do a bunch of other work to get it to only appear on the things that you want it to appear on. So what's cool about this tool is it allows you to do all that, and you can essentially use any type of material on it. The only thing that it does not support is going to be nanite displacement on the actual procedural mesh, but other than that, it should support just about every other type of material that you can apply to it. Now, another cool thing about this tool is it allows you 3 different methods of projection. So the basic one is called standard, and that is literally just projecting onto a surface in a square shape, and you can control the size of it. The other method is spline path, so you can actually draw out a spline path and it will project along that path. You can control the overall width as well as the individual width for each point along that spline. And then the other method is called spline volume. This allows you to create a closed spline shape, and it will project within that shape whatever you want as an overlay. All right, so let's get into it, and I'm going to give you a dive into the features of this tool. All right, so in this scene, first of all, I'm using the default Unreal Engine 4 editor layout, just to have everything on a single screen for the purposes of this video. So this layout might look a little different than your default Unreal Engine 5 layout, but it's just so I can have everything on one monitor. So as you can see in my scene, I've got 10 different overlays in my scene. And they're using different methods, different materials, and all that stuff, so I'll kind of break that down. So I'm going to go in and start with the most basic, which is this one here. So with this selected, you can see that under my properties, or my details panel, I have an overlay tool section. Under here, you'll see that I have a bunch of different options. I'll go through those in a little bit. The first one is refresh overlay. Basically what this allows you to do is anytime something below the overlay has been modified, it's not going to know what to do unless you either move it or hit refresh overlay. So another thing this does is it also refreshes the material parameters. So the overlay tool, I've built it in a way where it actually pulls the material parameters of the material applied to it. So if you swap out a material and you don't deselect it and then reselect it again, then those parameters will not update unless you hit refresh overlay. So hitting refresh overlay will update the projection onto the objects that it's projecting onto if they've been moved, and it will also update the material parameters based on whatever new material has been applied to it. Right? So if I go in here, for example, let's say I move this sphere over. Now you can see the overlays on here have not been updated. They're just hovering there. But if I go back in here and hit refresh overlay, you can see it's going to reproject onto what it can project onto. Right? So I'm going to set that back to where it was. Go back in here, refresh it again, and now you can see that it updates. Right? So moving down from there, you'll see that we have the material parameters. It is automatically pulling in and creating the groups from the material that it's using. So if I load up this material here, which is called Overlay 1. I'm just going to close this 3D viewport here. And in here, you can see all of those groups that I've created in the material instance down here, and those are all replicated in here. So with material parameters, let's say I just collapse all of these. Okay, you can see that it's one-to-one replicating all of those groups, and then under those, it's pulling the individual parameters from those groups. The only things that it's not pulling in are going to be checkboxes, so static switch parameters. It's maybe a feature I add a little bit later, but it was causing some issues, so I decided to just get rid of it. So it'll only pull in all the other parameters from the material. And what this allows you to do is you can have your material instance, right? And then per instance of the actor, even though they're all using that same material instance, you can go in and adjust those values. So let's say I want to go into this one and adjust the tiling, for example, right? I can go in and do that independent of the material instance itself. And then that same material instance is also being used for everything else that looks the same as this leafy twig ground. But you can see that those haven't been updated, right? So I can do it per overlay instance, which is really, really cool. And all of those material parameters that are in here, you can see that those are automatically updating. And I can show you how that works as well if I go in and let's just say I select a different overlay. Let's say this one, and I'm going to grab this material from it. Go back into this overlay. And you can see all the material parameters right here right now, right? I'm going to update this with this blood material. You can see these material parameters have not been updated, but if I hit refresh overlay, they are. Okay, and you can see that this material instance, the only parameters that it has are going to be your textures. Okay, so I'm going to go back, I'm going to refresh that, put that back to where it was, and now you can see my material parameters have been updated again to reflect that material that's been reapplied to it. Okay. So going back to this overlay, I'm going to minimize the material parameters. You can see here, I also have an overlay method, right? So this is what I was talking about before, where it's standard spline path, or spline volume. I have different overlays in the scene that I'll show you covering those in a minute, but in order to change that, all you need to do is select this from the dropdown. This is your material. You can also adjust your cull distance. So this is how far away from the view the actual overlay mesh will cull, right? So if I have this selected and I pull out, you can see that that one is now gone. Right? And you can also see that it has a transition fade. That's based on the mask in the material that I have working in combination with the cull. So this cull value here actually culls the procedural mesh. It culls the overlay completely. The cull in the material, which you can actually control through the material parameters down in mask, you can see there's a cull distance start and cull distance end. This will basically allow you to fade that out. So you basically want it to fade out before the actual mesh culls, or it's just going to pop in and out like you see the other ones doing, right? Okay, so that's what the cull values are. Now if we go down here, you can see under standard projection, which is what it's set to now, I can control the scale. So I can control the overall scale like this. I'll put this back on so you can see it. Okay, so I can control it that way. This material is actually using world space coordinates. You'll see that the textures are not stretching with it. It's just the overall size and the mask of that overlay. If I set it to relative scale, it's going to scale X and Y together. If I do it without relative scale, I can control X and Y independently, right? So it gives you more control over the size of that overlay and the shape of it. Now if I go under projection, this is basically going to control how the procedural mesh is projected onto the surface. So segment density is basically the subdivision of that procedural mesh, and then you can control the width subdivisions if you're using the spline projection. Normal offset is going to control how far from the surface it actually overlays, because once again, this is a mesh overlaying over the surface. This particular material I'm using uses parallax occlusion mapping. That's why it has the illusion of depth, which you can see here. But it is actually just a 2D material, so as you go farther down, you can actually see that happening. So what's going on here is I do have it with the normal offset of 0.5. So it's basically half of a centimeter off of the surface. I can bump that up to, let's say, 5 or even 10. And now you can see that's actually hovering quite a bit over the surface, right? This just allows you to control and fine-tune how your projection works. So if you're projecting over something that's highly detailed, maybe using nanite displacement on the surface that it's projecting onto, you might get some bleed through unless you adjust that, right? Trace distance. This is how far from the actual root point of the overlay that it will project down. So any object that's beyond 200 units in this case, it will not project onto. You can adjust that however you like. Per point width modifiers, I'll go into that later. That has to do with the spline-based projection. Down here, you can control what it projects onto, right? So right now it's on landscapes and static meshes. If I undo static mesh, you'll see it's no longer projecting on that static mesh. If I enable it, then it's going to project onto that mesh again. If I do target actors only, then I can select an array of actors. So if I do this, right now it's not projecting on anything, so it's just going to be a flat surface. And then I can say, hey, I only want it to project onto this, right? So it's going to project onto that. Now, it will not mask out what it's projecting onto, so just be aware of that. This is more designed for if you have it set to project on static meshes, you have a bunch of meshes over the static mesh you actually want it to project onto, then you can isolate just that mesh. And you can add an array of however many you want to. So if I go in here now and select the landscape here, for example, it's only going to project onto those two objects. And then I can delete those arrays completely, and now it'll just project onto all static meshes and landscapes. Okay. Now masking. This actually allows you to control the masking of the overlay itself. So this is separate from the masking in the material. This is actually using the vertex colors of the procedural mesh to mask out the overlay, right? So there's an edge fade, which you can see the edge fade values here, which is basically the edges of the entire overlay. And then you also have a detail noise mask, which is the inside of the projection, right? So if I go in here and do edge fade distance, you can see that's going to make the fade distance farther or narrower. If I set it all the way to 0, there is no fade around the edges. Set that back to default. If I enable or disable edge noise, it's going to control the noisy factor around the edge fade. I can also adjust the scale of that edge noise however I like, basically tiling for that edge noise. Edge noise seed is just going to kind of randomize that noise. That noise is not being generated via texture, it's actually being generated through like other methods. Whether or not I want detail noise. So once again, that's the noise inside of the projection. So now you can see I've disabled it's only the edges of the square that are being masked, right? So if I enable that detail noise, I can adjust the scale of that detail noise to kind of adjust that projection however I like. And I can also adjust the seed and basically randomizing that noise. If I get rid of both of these and then set this down to 0, you can see it's just a normal projection with no masking at all, right? Okay, so I'm going to set all that back to its defaults. Now I'm going to go over to this one. So this is a spline-based projection. So you can see I actually just drew out a spline along the surface, and I'm also telling it to only apply itself to landscapes, right? So this will not project onto any static meshes or anything like that. And as you can see, it's projecting on the surface. It's blending in really well. Now when I have it selected, you'll notice this this fizzing going on around the edges. That is temporal dither on the masked, because this is a masked material, not a translucent material. Translucent materials are a lot more expensive to render than masks, and for overlays like this, it's usually not going to be necessary, so I always recommend using masked materials and using dither to kind of fade out the edges like you see here. And then with it deselected, you can see you don't really see that fizzling unless you get really, really close to it, right? And it just helps it blend into the surface a lot better. Now, another cool thing about this, as I mentioned before, you can control the individual segment width. So under projection, per point width multipliers, you can see for point 2, I have it set to a 2 multiplier. And then for point 3, I have it set to a 3 multiplier. So you can see that's actually making it wider around those specific points. So as I go in and scale those, you can see what that looks like, right? So this just allows you to have more control over how your overlay actually looks. And you can draw out as many splines as you want to, or as many spline points as you want to. And you can also have them overlap each other and all that good stuff. Now, because this is a procedural mesh, if you overlap overlays on top of each other, you may get z-fighting if their surfaces align perfectly. In most cases, you will not. But you can also control the surface offset, the normal offset that I showed you earlier, to kind of have them overlap over each other to give one precedent over the other. It's not really going to be an index array for that. Now, another cool thing with these spline projections is based on the angle of the spline, you can actually have it wrap around corners. So that's what's going on here. I'm using the same spline-based method, but as you can see, my spline is wrapping around this surface. And because I have the individual spline points actually rotated towards that surface, it will project in that direction. If I go in and adjust this, you can see it's going to project in whatever direction I'm telling it to project into. So you could actually have a spline that goes here, projects over the top, and then rotates around slightly and projects on this side. You can really get away with a lot of cool stuff with that. Okay, and once again, for this example, I'm using a couple different materials. This material is using parallax occlusion mapping, and then the masking is just happening on the tool itself. And obviously, this blend on the edge is more noticeable because the thing that it's being applied to isn't anywhere near this color. It doesn't have any color variation. It's just sort of a solid gray blocks, whereas an actual material it's going to overlay onto, you'll see it blends a lot better. Now, this is another example of the same thing. So this is using a spline overlay, but in this case, the material is different. Instead of using the fade out on the edges, it's using a mask specific to this material. So this will allow you to have things like leaves over your surface or any kind of scatter or whatever it is, which is the same thing I'm using over here, right? So you can imagine these being rocks for a rock path or snow or whatever it is, and you want to have them cut out specifically with that mask, you can do that. And all of those controls and everything, you can adjust how that looks, can be done in your material. And it supports everything with substrate as well. So if you want to have, glints on your snow or whatever it is, you can do that too. Okay, and this is another example of that same thing. This is just a standard projection again, but it's just projecting a masked out leaf material. And since that's applied to this, I can also go in and adjust things like my tiling, right, for those leaves. I could even apply a different mask that maybe masks out the edges completely, whatever I want to do with it, right? I can control it a lot more easily that way. And this is another example. So this is a standard projection again, which is this one. Now this is just a standard projection, but I have it angled toward the wall, right? So if I angle it like this, you see the projection isn't going to go towards that wall because it's not within its field of projection, right? So I can kind of tweak that around a little bit. So let's say I want a nice little blood splatter and it splatters on the wall and the floor and all that. Now, once again, the projection itself is a mesh. So you can see here that it's not 100% aligned where this little crease is because it doesn't have enough geometry to be adjusted into that. But what you can do is under your projection, you can actually control the segment density. So if I change this to like 150, and let's say the width subdivisions to 20, I can get a better value out of that, right? So you can control the density of that projection. It's really up to you how you want to utilize that. In most cases, you won't have to adjust it. The default values work just fine. Okay. And there's another one where, with the fade and all that good stuff, I can control the edge fade distance and all that. And it really just depends on how your material is set up because this will require a masked material in order for these features to work here. But yeah, you can go in and add all that stuff. Now this particular material will not support this because this is actually just a decal material. But I use this one just to kind of show you that you can do kind of detailed masked out stuff like this, and it still retains all of its roughness, metallic, and all that. So you can use it as like a standard decal system as well if you like. And looking at all the spline points, you can see where I drew things out. Now the only one I haven't covered yet is the spline volume. So that's this one here. So as you can see, I have a outline shape with my spline, and inside of that shape is where it's drawing the procedural mesh, and it's basically being cut out based on that. So if I get rid of the edge noise and detail noise and set this down to 0, you can see exactly what that shape looks like, right? And you can see the hard cutoff from the geometry from that procedural mesh. I'm going to go back and set that back to where it was. So what's cool about this is you can draw it kind of any shape volume with your spline and cut it off to wherever you want, right? And I can tell it to project onto anything. Right now it's only projecting onto landscapes, but if I go into that tool and adjust that, now it's projecting on static meshes as well, anything within that shape that it's projecting onto. Now right now I have this facing downwards, but I can obviously take this shape and project it anywhere I want. So I'm going to take this back to where it was over here, just like this, and go back to my tool. I'm going to uncheck static meshes. And now I can also rotate this. So if I want to rotate the shape, I can do that. It's going to project into that shape, right? So it won't matter if it's down or sideways, wherever it is. Now, something you'll notice here is that it's basically not projecting on anything at that point. That's because where this cutoff happens is basically 200 units away from the surface. And remember, we set our projector to 200 units. So if I go into the tool, let's say I set it to 1,000. Now you can see it's projecting that entire distance, right? So it gives you a lot of control as to how you make your shape and do all that stuff. Now another thing I could do is if I wanted to, I could bring this point down. And then as you can see there, it's going to start projecting within that 200 units. Okay. Right. So once again, that just gives you a lot more control if you want to create a volume-based or spline shape-based projection. This one over here is doing the same thing. So this is a spline shape-based projection. But with this one, I'm not using any of the edge fall off stuff. I'm just using a slight fade around the edges. But the rest of it is just masked based on that material I showed you earlier. And yeah, and you can see that the surface under it has its own displacement because that is using parallax occlusion mapping. So you can see how it kind of hovers over the surface. So it's up to you as to how you want to utilize that. Now, one more feature of this, because it is a static mesh or a procedural mesh, and I'm using parallax occlusion mapping on these materials, I can actually use pixel depth offset. So pixel depth offset will basically allow you to have the parallax occlusion map surface intersect with real world geometry. So if I go into the material on this one, for example, if I go to POM, you can see I have PDO, which is pixel depth offset. I'm going to set this to 1, right? Now you'll see that that surface basically disappeared. So now what I can do is I can actually control the offset of that projection. And now you can see that I have that overlay with the height intersecting with my actual geometry. So as you can see here, if I take this, let's say I make this 8, that's my actual overlay surface, right? And as I drag this down, let's say I set it to 5.5 or 6 or even 7 or 6.5, you can see it's actually intersecting with the geometry. So parts of the geometry are coming through, the parts that are higher than that, like these twigs and stuff, are coming over the top. So you can do some really, really cool stuff with that. Okay. Now another thing I can do is with that PDO, that pixel depth offset, instead of setting it to 1, which is basically just on, I can actually just adjust its PDO value. And it's basically going to intersect the parallax occlusion mapping height map with the surface below it, right? As you can see there. Okay. So it gives you a lot of control over how you utilize the overlay tool. And once again, all these examples, the example with the leaves and the branches and everything is using parallax occlusion mapping. These leaves are just using standard albedo with a normal map. The blood is just normal roughness and albedo. But you can utilize pretty much any type of material as long as it's not using nanite specific features on your surface, right? Now, another cool thing is with that refresh, is the last thing I'm going to touch on, you can select all of your overlay tools if you like and click on refresh, and it'll refresh all of those tools. And it also does it in sequence, so it's not doing them all at the same time for efficiency, so you don't have to worry about doing, bunches of them all at once and then it crashes the editor or anything like that. Right? All right, now I'll show you what the actual overlay looks like, the geometry it's creating. So if I go into wireframe, you can see the overlays, how they look. You can also see that by going into lit wireframe, and you can see how they look on the surface. Okay. So I'm going to wireframe, so it's a little easier to see. So as you can see, they're not extremely dense. The ones that are extremely dense, I've adjusted the default values on. So if I go into this path version, right, and then I go into my projection, and I can control the segment density, which will control the density along the path, right? And I can control my width subdivision. So this is the width density, right, along that path. So that gives you a lot of control there. Now, if I go into this overlay, which is a standard projection, you'll see that my segment density controls all that, but my width subdivisions will not do anything because this is not a spline-based projection. It's only designed for spline-based projection. Now, if I go into this one, same thing, right? But the segment density does apply still. Right? And the reason you want to adjust your density for certain surfaces, if I go back in here, let's say I start reducing this density, you'll start to see the surface below pop through because it doesn't have enough geometry to morph to it, right? So that's one of the reasons I adjusted the density there. And then if I go back into wireframe, you can actually see that it fades out the mesh completely based on the cull distance, right? So it's not just culling the visual aspect of it. So this is how you can basically control your efficiency in your scene. And honestly, in most like gaming environments, if you're walking around and you have it set to a fade value as you walk in and out, specifically pay attention to this one here. This is the one that's actually using a fade. If you use a fade value with it, it's going to be a lot less noticeable, especially if it's projecting onto like a landscape surface or something like that. So you can combine the camera fade distance of the material with the actual cull distance of the overlay to get the effect that you're looking for. Now, in order to add the overlay to your scene, it's very straightforward. You click on the plus over here, type in overlay tool, and you can just drag it in. By default, it will not have a material assigned to it, and it's going to be using the standard projection method, right? And once again, you can just change that from here. So if I change that to there, change that to there, it gives you all those different values you can control. So I'm going to delete that. Now, in order to enable it, once you add it to your project, if for some reason it's not enabled, you just go into your edit plugins, go into overlay and overlay tool, and just check this box. It may or may not ask you to restart, and then you're good to go. And that's pretty much it. So there you have it. This is a very efficient and very controllable method of adding overlays onto your surfaces. And if you have any specific feature requests for it, please let me know in the comments. There are a couple that I can think of that I may be adding at a later date as just a free update to the tool.